All right, so for part one, we just need to plot the points with these given polar coordinates. Okay, so I always start with the angle, so I'm going to find 5 pi over 4, so that's going to be down here. I also like to label where that angle actually is, because remember the radius can actually make us go in the opposite direction. So when we have a positive radius, we're just going to go 2 in this direction. So we end up with this point right here. When we get over to b, we'll use the negative angle to figure out where 2 pi over 3 is. So it's right there. And I'm just going to pretend like that radius is 2 and not 4 because I didn't give you enough lines for a radius of 4 for whatever reason. Remember, I like to label that here is where negative 2 pi over 3 is. So I know I'm going in this direction. So I get a point right there. Down here for C, we start with the angle. So here is pi over 2, and we mark off where that angle actually is. And now we'll see why we do that, because this negative radius, and again, I'm going to treat it as negative 2, tells us to go in the opposite direction from where the angle is. So we're going to end up way down there. When we're over here, again, start with the angle. So I'll do negative 5 pi over 6. Mark where that angle actually is, a negative radius. I'm pretending it's negative 2. Means we're going to go in the exact opposite direction as that. So we end up over there. For 2a and b, we just need to find some other polar coordinates that match the given set. So I'm going to first just do a quick plot of this. So this is at pi over 6 and 2 in that direction. We have a couple different options here for the different ones that they're asking us for. I'm going to start with this positive radius here. So if I'm positive radius, it means I need to end up on this side. So I'm just going to use a negative angle to come all the way around. So that's going to be a negative 11 pi over 6. Now for the two negative radius ones, that means that I need to end up over here. So I'm going to use a positive angle to get here. So that's 7 pi over 6. And a negative angle, which is negative 5 pi over 6. And we're done. Same idea over here. We have 4 and a negative 120, so I'm just going to quickly sketch that. So a negative 120 is right here on this side. 4 is going in that direction. So if I want a positive radius with a positive angle, I just need to come all the way around the circle in a positive way. So that's going to be 240 degrees. For the two negative radius ones, I need to end up over here. Okay? So positive angle, that's just going to be 60, and a negative angle, that's just going to be negative 300. And there you go. For 3a, b, c, and d, we've been given a polar coordinate, and we're being asked to convert it back into rectangular xy. So I'm just going to be using these equations here, x equals r cosine theta, and y equals r sine theta, to help me figure out what these are. So first one, we got square root of 3 cosine pi over 6, comma, square root of 3 sine pi over 6. So now I just need to evaluate what these are. So let's see, cosine of pi over 6, that's a square root of 3 over 2. And then we have sine of pi over 6 is 1/2. Okay, so if I simplify these, we have square root of 3 times square root of 3. So that's just going to be 3 over 2. And then over here I have a square root of 3 over 2. So these are the xy, for those are theta. When I'm over here, I actually find with the quadrantal angles, it's almost always easier to just sketch a graph of it. So if I sketch a quick graph at pi, but with a negative angle, I'm going to end up over here. So that's just going to be the point positive 8 comma 0, where these are xy. Remember that those are r's and thetas. 3c, we're just going to do the same thing. So I got negative 4 cosine of a negative pi over 3, comma, negative 4 sine of negative pi over 3. So we just got to evaluate this. Cosine of pi over 3 is going to be 1/2. It's positive when we're in the fourth quadrant, so I have a positive 1/2. And here this is going to be a negative square root of 3 over 2. Okay, so that's going to be negative 2, comma, positive 2 rad 3. And there we go. Same thing for D. They just gave us a big angle over here, so I'm just going to find this coterminal one, so that's going to be 5 pi over 3. So I basically subtracted 2 pi, which is 6 pi over 3, out of that to get the 5 pi over 3. So now I'm just going to do 16 cosine 5 pi over 3, 16 sine 5 pi over 3. So cosine of 5 pi over 3 is actually the same as negative pi over 3. So we can just take the same answers that we already got. That's going to be a positive 1/2. This is going to be a negative square root of 3 over 2. I forgot my little parentheses there. So this is going to end up being 8 comma negative 8 rad 3. And we're done. For a and b, we're taking these rectangular coordinates, so x, y, and converting them into r's and theta with a very specific interval of theta needs to be between 0 and 2 pi. So I personally find it's always easier to just graph these. So 4, 4 is going to be right here. So now I can recognize this as a 45, 45, 90 triangle. So this is going to be a 4 rad 2. So I already have the radius and I already have the reference angle. So if I want to know what this point is, it's going to have a radius of 4 square roots of 2 and then an angle of pi over 4. I have to use radians because they gave us this in radians. Now there's another point that we could find that's between 0 and 2 pi that works just as well, and it's just going to use a negative radius. So I use negative 4 square roots of 2 and then I just move my angle over here, which is 5 pi over 4. So these are going to be the two different points that satisfy the given theta requirements. Same idea with b. We'll just graph this real quick. So this one's a little bit trickier to maybe recognize at first glance, but if we just kind of ignore the over 3, we have a 1 and a square root of 3, so this is going to be 2. So then we have a 2 over 3, and that's going to be a 60. So we know our radius is going to be 2/3. Our angle is going to be 60, so that's pi over 3. We can also pick this angle down here with a negative radius, and so that's going to be 4 pi over 3. So these would be the two different points that work with that theta value. 5 is the same as 4, except we have a new interval, and I'll just remind you that basically we use negative angles if we're in quadrant 3 and 4, and if we are in quadrants 1 and 2, we'll just use positive angles. So that's really all that means for us. So I'm going to graph this right here. So that's going to be positive, negative, so we're down here in quadrant 4. I recognize this as a 45, 45, 90 triangle, so its pattern is always going to be x, x, x rad 2. So I'm going to multiply the square root of 3 times the square root of 2. That's going to give me a square root of 6. So that's my radius. So let's think about this. In order to get down here, I'm going to use positive square root of 6, and then I could use 7 pi over 4, but that's in quadrant 4, so I'm going to use a negative angle instead, so negative pi over 4. If I use a negative radius, that's a 6, I swear. I need to end up over there, that's in quadrant 2, so I'll use a positive angle, that's going to be positive 3 pi over 4. Okay, so those are the two different values that work with the given angles. B, similar to the other B, we just have to recognize what's going on with it. So we have a 1/4 and a negative square root of 3/4, so this is a 1 square root of 3, this is going to be a 2 over 4, which I can reduce to 1/2, and that's going to be a 60. Now, in the fourth quadrant, we have to use negative angles, so I'm going to have positive radius, with a negative pi over 3. And then I can use a negative radius with a positive angle, because I'll be in quadrant 2 for that one, and that's going to be 2 pi over 3. Woo! For 6, A, B, C, and D, we're being asked to convert the polar equations into rectangular equations. So we're basically looking for one of these 4 things way down here. And if we don't have them, we will try to create them by multiplying both sides by something. So here, I'm just going to get these out of the denominator by multiplying them to the other side, and I'll distribute that r through as I do that. So I'll get 3 times r cosine theta minus 8 times r sine theta, and that'll equal 1. R cosine theta is x, so this is really 3x. R sine theta is really y, so that's really a minus 8y equals 1. So I know that this is going to be a line. Done. For b, when I'm looking at this one, I really want this to be r sine theta, and there's no r there, but if I just multiply both sides by r, so I'll square that side and get it over here, I now have the r sine theta and an r squared, so I can replace this side with x squared plus y squared. And over here I can have 26 r sine, which is really y. Now, when we're in this, we always have to just keep going and put it in the standard form of a circle or an ellipse, whatever this happens to be. So I'm going to have x squared plus y squared minus 26y plus something equals plus something. So that's going to be 26 divided by 2 squared, so that's 169. So So I get x squared plus y minus 13 squared equals 169. So this is going to be a circle. It has a center at 0, negative 13, and it has a radius of 13. Same idea for c. We need these to have r, so I'm just going to multiply an r by everything. So I'll get r squared minus 3r sine equals 6r cosine. The r squared over here is going to become x squared plus y squared using the formula. This is going to become minus 3y, and I'm just going to subtract this over at the same time, so I'm going to have a minus 6, r cosine is really x, equals 0. Now I'll just rearrange things just to kind of group things together and leave my little blanks for when I complete the square. So over here I'm going to be adding 9, and here I'm going to have 3 halves squared, so that's 9 fourths added to both sides. So I'll have x minus 3 squared plus y minus 3 halves squared equals whatever 9 plus, that's going to be, I think that's 2, so 11.25. And we recognize this as a circle, center 3 of comma 1 half with whatever the square root of that crazy number is. Done. Kind of ran out of room over there, so I'm just going to do it down here. I'm going to just multiply this to the other side, so I'm going to get r minus r cosine theta equals 1, so I distributed the r through. And let's see, I don't have anything particularly for r, but I can solve this equation. So I'll have a plus or minus square root of x squared plus y squared. We'll deal with the plus or minus later. Minus, this is going to be an x equals 1. I'm just going to add this x to the other side, so I'll end up with 1 plus x. And I'm just going to square both sides to get rid of this plus or minus over here. So I'll get x squared plus y squared equals, and if I square that and FOIL, I will get something like that. So the x squareds cancel, and I'm left with a y squared equals 2x plus 1, and we recognize this formula as a parabola that's opening sideways. Okay, 7, A, B, C, and D, we're given a rectangular equation and we want to convert it into polar. So again, I'm going to be using those sets of formulas over there. So y is really r sine theta, so I'm just going to rewrite this as r sine theta equals 2, and then we typically try to solve for r equals, so I'll just divide the sign to the other side, so that's 2 over sine theta, and we can rewrite that as 2 cosecant theta. Boom, done. Replace the x and the y with the r's and cosine, so I'll have 3r cosine theta plus 2r sine theta equals 4. I'm going to factor an r out of all of that stuff and then just divide it to the other side. So I'll have 3 cosine theta plus 2 sine theta. And that's as much as I can do. You can't bring these to the top because of the addition sign there, so we just leave them. For c, we could replace things immediately, but it's much easier if we actually FOIL this stuff first. So I'm just going to FOIL that out. I'll get y squared plus 6y plus 9 equals 25. So now I have an x squared plus y squared, which we know is really r squared. I have a 6y, which I can rewrite as 6r sine theta. And I can actually take this 9 and move it to the other side, so I'll have a 16 there. So this one, we're not going to be able to solve it perfectly for r equals. We'll just end up leaving it as r squared equals 16 minus 6r sine theta. I think that's the nicest we're going to get that one. For d, again, we'll FOIL everything out. It makes our lives much easier. So I'll have x squared minus 2x plus 1 plus y squared plus 4y plus 4 equals 1. This x squared and y squared are going to become r squared minus the 2x. That's going to become minus 2r cosine theta. This 4y is going to become plus 4r sine theta. And then I will just subtract this 4 to the other side, and the 1's cancel each other out. So again, we're not going to be able to get a perfect situation here, so we'll just solve this one for r squared, I think, by adding these to the other side. So I'll have 2r cosine theta minus 4r sine theta minus 4. And that's, I think, the best we're going to get with that one. For 8, we're trying to write the complex numbers, a plus bi, in trig form. So that's r cosine theta plus ri sine theta, which we often abbreviate with the KISS notation I have up there. And what this is essentially asking us is the same thing as switching from rectangular to polar. So this negative square root of 2, square root of 2, I can just graph that real quick. So it's going to be over here, square root of 2, square root of 2. And I recognize that this is an x rad 2. So if I do that, I'll get a radius of 2, and this is a reference angle of 45. So I can rewrite this as 2, and then kiss, and then our angle 3 pi over 4. I forgot the over 4 when I was talking out loud. My bad. B, same exact idea. We'll just do a quick little sketch of this thing. It's going to be over here. We got square root of 3 over 2, 1 over 2. So this is a square root of 3, a 1. This is going to be 2 over 2. So that's going to end up being 1, and 30 is our reference. So this is going to be 1 kiss pi over 6. Done. Here we have 1, negative 1. So recognizing this as a 45, 45, 90. Radius is going to be square root of 2. So I have square root of 2 kiss 7 pi over 4. Now just remind you that we really prefer these things to be positive radiuses and positive angles, and I'm like 95% sure that by definition they have to be that way for it to work nicely with all of our formulas over here. For 1 plus 0i, so that's just going to be right there. That's just going to be a radius of 1 and an angle of 0. So this is 1 kiss 0. I don't know why I decided to make that degrees. Radians are perfectly fine. So for 9, it literally goes against what I just said in the last one, which was that we try to avoid negative radiuses, and there's a negative radius, but oh well. We're just going to expand this out by remembering what KISS actually stands for. It's cosine plus I sine. So this is really negative 3 cosine of 30 plus a negative 3 I sine 30. And then we just need to evaluate what cosine of 30 and sine of 30 are. So this is going to be a negative 3 times square root of 3 over 2. Minus a 3i times a 1/2, and so we'll just rewrite this one last time, and we end up with that. So this trig form is that in standard form. Same exact idea over here. I'm just going to keep the square root of 2 out first, just so it's a little bit easier. I'm doing cosine pi over 4, that's square root of 2 over 2. Sine is going to be square root of 2 over 2, and I have the I for the second one. Now I'll just multiply this square root of 2 through, so I'm going to get square root of 2 times square root of 2 is 2 over 2, so this is 1. Same thing's going to happen over there, so I just get 1 plus I. When I'm over here, we could do it out that way. I find it easier with quadrantial angles to just graph it, so this is going to be over here, so I recognize this as negative 6 plus 0i. Same idea over here. I'm going to do cosine of 11 pi over 6. That's going to be a square root of 3 over 2. Plus sine of that, that's actually a negative 1/2 I. And I'll just distribute the 5 through. 5 square root of 3 over 2 minus 5/2 I. Done. For 10, we're given two complex numbers written in trig form, and we're being asked to multiply and divide them. I have the multiply formula up here. Just realized I never wrote the division one, but it's the same except we divide the radiuses and subtract the angle on the inside. So if I do the multiplication, I will get 3 times 9 kiss, add the angles, 150 plus 60. Now I'll just kind of simplify this down, so I get to 27 kiss. This is going to be 210 degrees, and I'll just keep going to put it in a plus bi form. So I'll have 27, cosine of 210 is going to be a negative square root of 3 over 2. Sine of 210 is negative 1/2 times that I value, so I end up with a negative 27 rad 3 over 2 minus a 27 over 2i. So that's what these two numbers multiplied together equal. Now for division, I'm going to be doing z1 divided by z2, so I take the radiuses and divide them. 3 divided by 9, kiss, and the angles subtracted from each other, 150 minus 60. So I get 1/3 kiss, and then this is 90. Okay, so when it's quadrantals, I think it's easier to just graph it. So I'm going to have 0 plus 1/3 I. Done. For 5a, we want to use De Moivre's or De Moivre's theorem. So that's this one right here, where we basically raise it to a power and multiply the angle by that power. So the first thing I need to do here is convert this into trig form. So I'm going to just sketch this over here. It's negative 2, so I'm over here. So this is negative 2, 2. This is going to be 2 rad 2 with an angle of 3 pi over 4. So I have 2 rad 2 kiss 3 pi over 4. And that is what I'm actually being raised to the 5th power here. So I'm going to just follow the formula. So I'm going 2 rad 2 raised to the 5th power. Kiss of 5 times 3 pi over 4. So I'm going to do a bunch of scratch work off on the side, basically to try to figure out what this is. I'm going to have 2 to the 5th times, let's see, I'm going to be able to pull 2 of these out, 2 times 2 with an extra square root of 2. So I have 2 to the 7th square roots of 2. I'm pretty sure that's 128 rad 2. Kiss. This is 15 pi over 4, and that's coterminal for 7 pi over 4. So that's really what I'm being asked here. And now I'm just going to convert this stuff. So I have 128 square roots of 2. Cosine of 7 pi is going to be square root of 2 over 2. Sine is going to be a negative square root of 2 over 2i. So I'm just going to distribute this through. Square root of 2 over square root of times square root of 2 is going to be 2 over that 2. So those cancel, so I'm left with just 128 minus 128i. Now, if we were to have done this the long way, which would be to actually FOIL this out 5 times, that would have taken us 9 years. Speaking of taking 9 years, b, we're being raised to the 100th power, so this would actually take you 9 years to do, probably. I'll just do a quick sketch so I can figure out what's going on with it. It's a 45-45, so I'm going to have square root of 2 kiss, and then it's going to be, what is that, 5 pi over 4? Yeah. And that's when I'm being raised to the 100th power. So I'm going to have the square root of 2 raised to the 100th, kiss 100 times 5 pi over 4. Okay, so let's try to figure this out. This right here is really going to just be 2 to the 50th power. I have no idea what that is. That's a ginormous number. Kiss. And here, this is going to be 25 times 5, 125 pi. Okay, so that's an odd multiple of pi, so it's going to actually end up just being at pi. So I know this is going to be over here, so I'm going to have 2 to the 50th, plus 0i. Done. 12, we're being asked to find the 5th roots of 3 rad 3 plus 3i, so I'm going to be using this nth root formula over here, where we have that k value. K is going to allow us to find the 5 different roots. First thing I need to do is put this into trig form, so I'm just going to sketch a graph of this. So I have 3 rad 3 and 3, so I'm recognizing this as square root of 3, 1, so this would be times 2 up here, so it's going to be 6, and that is a 30. So what this really is 6 kiss of 30, or pi over 6. Okay, so now I'm just going to apply the formula. I'm going to have the 5th root of 6 kiss the angle, pi over 6, plus 2 pi k, divided by the roots that we want, so 5. And then I always like to simplify this, so this is really pi over 30 plus, and then I want to maintain the 30 here, so that's going to be 12 pi over 30k. So the reason I do that is once I get the first angle, I can just add 12 to the numerator for everything else. So I'm going to have k equals 0, k equals 1, k equals 2, k equals 3, and k equals 4, and I can stop there because we started at 0, so we have 5. First one, let's see, well actually they all have this 5 root of 6. That is not English, that's not how you pronounce that. Oh boy. Getting delirious here at the end. Alright, so all of them have all of that, so I just start with that. When k equals 0, I'll just have this pi over 30, then I'm just going to add 12 each time. So 1 plus 12 is 13 pi over 30, then I'll have 25 pi over 30, 25 is 37 pi over 30, and this is going to be 49 pi over 30. None of these are special angles, so that's my final answer for this. These are the 5th roots of 3 rad 3 plus 3i. All right, we made it, last one. I mean, I don't even know if anyone's watching these things, so I could just be talking to myself for the last 5,000 hours, it feels like. 4th root of -1. First thing you need to do is put this in trig form, so this is really -1 plus 0i, so if I graph that, that's right there. So that's going to be a radius of 1 and an angle of pi. So I'll just follow the formula. I have the 4th root of 1, kiss, the angle pi plus 2 pi k, all over 4. I don't need to simplify that at all, and that's just going to end up being 1. So I'll have k equals 0, k equals 1, k equals 2, and k equals 3. That gives me the 4 that I need. So let's see, we're going to have 1, 1, 1, 1, and then kiss for all of these, and parenthesis, parenthesis, parenthesis. Let's see, when we have 0, we'll have pi over 4. Then I just need to add 2, so this is going to be 3 pi over 4, 5 pi over 4, and then 7 pi over 4. These are all special angles, so I need to go the one step further of putting them back in standard form. And they're all 45, 45, so they're all going to end up being square root of 2 over 2, some variation of that. We just have to pay attention to the quadrant. So like for here, the first one's negative, second one's positive. Next one, they're both negative because we're in the third quadrant. Last one, first one's positive, second one's negative. And these are our 4 answers for the 4th roots of -1. Woo! We made it!